with displacement being defined, what we can then do is we can take a look at solving some or a sample problem here. So you have a flock of geese, you're tracking their migration, and you find that they travel 500 kilometers west and then 100 kilometers south. And you're asked to find two things here, the magnitude of the displacement, as well as the total distance they've traveled. Now, in order to do this, what I recommend you do is you draw out these two pathways. So you can turn a compass into a Cartesian plane. And so what your geese are doing is, first of all, they're traveling 500 kilometers straight west, and then they're going to travel 100 kilometers straight south. And again, it's never necessary to draw these to scale, but we're going to put in the two displacements that we have here. All right, and we'll omit the units just to make our lives a little easier. Now, their displacement, of course, is the addition, or their total displacement is the addition of these two paths. So in blue here. And so what we're going to want to do is we're going to want to figure that out. Now, the easiest way to do this is to do it in Cartesian notation. So we're going to start off with the red pathway. The red displacement is 500 west. This is a horizontal style displacement, so we're going to put it as an x-coordinate, and it's going to be negative because typically speaking, right or going east would be defined as positive. We're going to do the same thing for the south displacement. Again, it is a vertical displacement, so there is no horizontal part to it. And in terms of the vertical part, we're going downwards as we've drawn it. So we're going to draw that as a negative. Now, when we add these things together, again, the x and the y components are separate. So all we need to do is add up the x's and add up the y's. So to do so, 0 or negative 500 plus 0 is negative 500. And 0 plus negative 100 is negative 100. This here is our total displacement. Now, this total displacement is a vector quantity. We can do a quick sanity check. It's negative in both its components, so it's going to be going down and left, so that checks out. But what we're asked for here is the magnitude. Whenever you're asked to find a magnitude, it's like finding a hypotenuse. So what you can do here is the magnitude of your displacement squared is equal to the x part squared plus the y part squared. And again, whenever you're using the Pythagorean theorem, you do not have to worry about the sign. In fact, it's easier if you omit it. And so with that being said, we can find the magnitude of our displacement utilizing this Pythagorean theorem. And if we do so, we'll get about 510. And it'll be in kilometers because that's the unit that we started with. So that's the first part. Again, when you're dealing with displacements, they are vectors, and you have to treat them as such. Total distances are a little different. When we're adding up total distances here, we're treating everything as if it were a scalar. So what that means is if we want the total distance, so all right, this is distance total, all we need to do is just add everything by ignoring the directions. So we start off going 500 kilometers west, so that's 500 kilometers we're going to travel, and then we go 100 kilometers south. All we do in each of the instances is simply add the magnitudes of each of our travel trips together. Putting these all together, you get a total distance of 600 kilometers. So what you'll notice here is they are different. One thing that is almost always true is you'll notice here that the magnitude of the total displacement is smaller than the distance traveled. That is almost always true. In fact, the only time in which the magnitude of the displacement and the distance traveled is the same is if you travel literally in a straight line without changing direction. The minute you change direction, your total displacement will be smaller than your distance traveled.